There is a picture most people carry somewhere in the back of their minds, a picture of the very beginning. It involves a brilliant white flash, an enormous burst of radiant energy erupting from a single point, light flooding outward through nothingness, the cosmos announcing its own birth with a blinding proclamation of photons. It is a compelling image. It is also, from the perspective of rigorous modern cosmology, almost entirely wrong. The universe did not begin in light. It began in a silence so profound, a darkness so absolute, and a cold so deep that the word cold barely begins to describe it. The light came later. The light was not the origin. The light was the wreckage. To understand why this matters, we need to go back further than most people think is even possible, further than the hot, dense plasma that cosmologists call the early universe, further than the first formation of atomic nuclei, further than the first fraction of a second when quarks bound themselves together into protons and neutrons. We need to go back to a period of cosmic history so strange and so geometrically violent that the ordinary concepts of heat and matter and light simply did not apply. We need to go back to the epoch of inflation. Picture a rubber sheet stretched across a completely dark room. Now picture that sheet stretching, not slowly, not at a reasonable speed, but at a rate so catastrophically fast that any mark you draw on it, any wrinkle, any imperfection, is almost instantly diluted into irrelevance. The marks do not disappear. They are simply separated from each other so rapidly that the sheet between them becomes, for all practical purposes, geometrically flat and featureless. This is what cosmic inflation did to the geometry of space itself. Roughly 10 to the power of negative 36 seconds after whatever event initiated the universe, a field, not a material substance, but a fundamental feature of the physical vacuum, began driving the geometry of space outward at an exponential rate. This field is what physicists call the inflaton field. It was not made of particles. It had no photons. It radiated no heat. It was a smooth, cold, invisible structure embedded in the fabric of space-time itself, and it was the engine of the most violent expansion in the history of reality. The critical word here is cold. This is the point where the standard popular picture of the Big Bang collapses completely. During inflation, the universe was not hot. It was not a fireball. It was not a blinding wall of radiation expanding outward. The geometry of space was expanding at an almost incomprehensible rate. But the temperature of the universe was being driven downward, not upward. Every fraction of a second that inflation continued, the volume of space increased enormously, and any residual heat or energy density within that space was diluted to near absolute zero. The universe was freezing. It was stretching and freezing simultaneously, a dark, geometrically violent freezing void. Think about what this means physically. Before the epoch we normally call the hot Big Bang, before the first nuclei, before the first quarks, before any particle physics as we understand it, there was a period when the entire observable universe was contained within a region smaller than an atomic nucleus, expanding at exponential speed, with a temperature approaching absolute zero, no photons, no matter, just the cold, smooth, geometric expansion driven by the energy stored within the inflaton field. This was the true beginning. Not a flash of light, but a dark, screaming expansion of geometry through pure vacuum. The inflaton field, which was driving all of this, had a specific mathematical character that is absolutely central to everything that came afterward. Physicists describe it using what they call a potential energy landscape, a mathematical shape that describes how the energy of the field changes depending on its value. Think of a ball sitting on top of a very smooth hill. The ball has enormous potential energy by virtue of its position. As long as it stays near the top of the hill, the system remains relatively stable. The inflaton field during the inflationary epoch was behaving something like that ball, not at the very peak, but on a very flat, very gradually sloping portion of the potential energy curve. Because the slope was so gradual, the field rolled very slowly down that mathematical hill, and this slow roll was precisely what sustained the inflationary expansion. The field was releasing its potential energy in a controlled, prolonged manner that kept the geometric expansion going. But here is what makes this story so extraordinary. The hill does not stay flat forever. The potential energy curve has a bottom. The mathematical landscape through which the inflaton field was rolling eventually steepened, and then it terminated in what physicists describe as a potential well, a valley, a minimum of the energy function. When the inflaton field finally rolled down the steepening slope and reached the bottom of this geometric valley, the epoch of inflation ended. The exponential expansion of space stopped. And what happened next was one of the most violent thermodynamic events in the history of the universe. To understand what happened at the bottom of the potential well, think about what happens when you take a thick rubber band and you stretch it to its absolute limit and then you release it. It does not simply spring back to its original shape and stop. It oscillates. It vibrates back and forth, converting the potential energy of its stretched configuration into kinetic energy of motion, back and forth, with decreasing amplitude as the energy is gradually dissipated. Now imagine that rubber band is not a physical object, but a fundamental field permeating every point in space, and instead of losing its energy to gentle air resistance, it is losing its energy to the laws of quantum field theory. The oscillating inflaton field did not simply vibrate and stop. Its oscillations were so energetic, so massive in scale, that they resonated with every other quantum field in existence. The inflaton field was, through the mathematics of quantum mechanics, coupled to the other fundamental fields of nature. As it oscillated, it poured its energy directly into those fields, creating particles and antiparticles from the vacuum at a catastrophic rate. This process is what cosmologists call reheating. The name is technically accurate but somewhat misleading. It implies that the universe had been hot before and was being warmed up again. What was actually happening was more like ignition. The universe was not being reheated, it was being heated for the first time. The cold, dark, geometrically flat void that had existed throughout the inflationary epoch was being flooded with energy for the first time through the mechanism of the oscillating scalar field pouring its stored potential energy into matter and radiation. The physics of this process is remarkable in its precision. The inflaton field, as it oscillated at the bottom of the potential well, was losing energy at a rate determined by its coupling constants, the mathematical parameters that describe how strongly it interacts with other fields. Physicists model this process using an equation that looks structurally similar to the equation describing a damped harmonic oscillator, the same mathematics that describes a pendulum gradually losing its swing to friction. But instead of mechanical friction, the energy dissipation was occurring through the production of real particles out of the quantum vacuum. Every oscillation of the inflaton field transferred a portion of its energy into the quantum fields of matter and radiation, creating quarks, leptons, gauge bosons, and critically photons. Let that last point settle for a moment. The photons, the particles of light, the entities that carry electromagnetic radiation through space, were not the original inhabitants of this universe. They were produced during reheating. They were manufactured from the kinetic energy of an oscillating scalar field that had previously driven the exponential expansion of empty dark space. The light was not there at the beginning. The light was generated by a process that occurred after the beginning, a process powered by the dying oscillations of a cold, dark, invisible field. This is not a semantic distinction. It changes the entire conceptual picture of what the universe is and where it came from. If you trace the origin of every photon currently traveling through the observable universe, every quantum of light that has ever been detected by any telescope or instrument, you find that its energy can be traced back to the inflaton field, to the potential energy stored in the geometry of the early universe before a single particle of matter or radiation existed. The light is, in a precise thermodynamic sense, the exhaust of the inflationary engine. It is what the universe produced when that engine finally shut down. There is another layer of this story that is worth examining carefully, because it touches on something even deeper about the nature of the universe we inhabit. During inflation, when the field was driving the exponential expansion, something was happening at the quantum mechanical level that left permanent marks on the structure of the cosmos. Quantum mechanics tells us that even the vacuum, even empty space, is not perfectly smooth. There are tiny quantum fluctuations in every field, random microscopic variations in energy and field value that are an unavoidable consequence of the uncertainty principle. Under normal circumstances, these fluctuations are vanishingly small and have no macroscopic consequences. But during inflation, they did. The exponential expansion of space was so rapid that these tiny quantum fluctuations were stretched from microscopic scales to cosmic scales before they could collapse back on themselves. A fluctuation that existed for a fleeting moment on scales smaller than an atomic nucleus was, within a fraction of a second, stretched to the size of a galaxy cluster. The expansion converted these quantum ripples into classical density variations, tiny regions where the inflaton field had slightly more or slightly less energy than the average. And because reheating produced more particles and more radiation in regions where the field had slightly more energy, these density variations were imprinted directly onto the distribution of matter and radiation at the end of inflation. These are the seeds of cosmic structure. Every galaxy cluster, every void in the large-scale structure of the observable universe can be traced back to a quantum fluctuation that was stretched to cosmic scale during inflation. The structure of the universe, including the very scaffolding on which galaxies formed and within which stars eventually generated the photons of visible light, has its origin in quantum randomness, amplified by geometric expansion during a cold, dark era that predates the existence of light itself. The thermodynamic sequence, laid out with full honesty, is this. The universe began in an energetic but cold and dark state driven by the potential energy of the inflaton field. Space expanded exponentially, diluting any pre-existing thermal content to near absolute zero. The inflaton field rolled down its potential energy curve and began oscillating violently at the bottom. These oscillations transferred energy to all other quantum fields through parametric resonance and perturbative decay. The universe reheated, reaching temperatures of perhaps 10 to the 15 or 10 to the 16 degrees Kelvin in an incredibly short time. Out of this thermal bath of newly created particles and radiation, the familiar hot, dense plasma of the early universe emerged. The photons that constitute the cosmic microwave background, the oldest light we can detect, were created during and after this reheating process, not before it. There is something philosophically profound about this sequence that I think deserves a moment of honest reflection. The question of origins, of what came first, is one that has occupied human minds across every culture and every epoch of history. And the answer that modern cosmology provides, when you follow the physics without flinching, is that what came first was geometry. Not light, not heat, not matter, but the cold, abstract structure of spacetime itself, energized by a scalar field that left no light and no heat in its wake until the very moment it collapsed. We are not living in the aftermath of a light-filled explosion. We are living in the hot, glowing, secondary radiation produced by the friction of a collapsing, dark, geometric structure. The universe is not a fireball that has been cooling for 14 billion years. It is the thermal exhaust of a dark, cold engine that ran on pure geometry and quantum field theory, and then transferred everything it had into the matter and radiation we now call reality. The cosmic microwave background, that faint afterglow of radiation that fills every corner of observable space, is not the echo of the original explosion. It is the cooled remnant of the reheating process, the final thermal product of those oscillating scalar field vibrations, stretched and diluted by 14 billion years of further cosmic expansion until it now sits at a temperature just under 3 degrees above absolute zero. When you look at the CMB maps produced by the Planck satellite, with their subtle variations in temperature across the sky, you are not looking at the direct light of the Big Bang. You are looking at a pattern that was first written in quantum fluctuations, then amplified by inflation, then converted into density variations during reheating, then imprinted on the photon distribution during the era of recombination. Layer upon layer of physical process, each one further from the original dark, cold, inflationary epoch. And yet, those original quantum fluctuations, those tiny random variations in the inflaton field during the dark era, are the ancestors of everything we see. The Milky Way galaxy was seeded by one of those fluctuations. The solar system condensed within a region of slightly enhanced density that traces its lineage back to a quantum ripple in a cold, dark, scalar field. The photons of sunlight that drive the biology of this planet were produced by nuclear fusion in a star that formed in a galaxy that coalesced from density variations that originated in the quantum vacuum during inflation. The chain of physical causation stretches back, link by link, to a cold, dark geometric void that contained no light whatsoever. This is the picture that modern inflationary cosmology gives us, and it is a picture that is considerably stranger, considerably more counterintuitive, and considerably more intellectually demanding than the simple image of a bright explosion. It asks us to accept that the universe began not in brilliance, but in darkness, not in heat, but in cold, not in the familiar forms of matter and radiation, but in the abstract mathematical structure of a scalar field rolling slowly down a potential energy curve. It asks us to understand that light, for all its centrality to our experience of the universe, is a late arrival, a secondary product, the thermal exhaust of a process that was already complete before a single photon came into existence. The light did not come first. The geometry came first. The darkness came first. The cold, silent, screaming expansion of empty space came first. And then, when the engine of that expansion finally burned through its stored potential energy and collapsed into oscillation, the universe produced its first light, not gently, not gradually, but all at once, in a catastrophic thermodynamic conversion that we call reheating, a process so violent and so rapid that it brought the temperature of the cosmos from near absolute zero to quadrillions of degrees in a fraction of a second. That is where the light came from. That is what the light is made of. And that, when you follow the physics with full rigor and without the comfort of simplified popular narratives, is the true picture of how the universe began.